welcome to Organic Odensday Wednesday on Curly Carbocation. If you like short form chemistry content, please subscribe and stay tuned. Today we'll be talking about nucleophiles and electrophiles, otherwise known as a Lewis base and a Lewis acid, respectively. Be sure to watch my previous Molecule Monday video on the definitions of acids and bases. Because Lewis acids and bases focus solely on the movement of an electron pair, we can view things that are organic, which might be something like an oil, as an acid or base, which is typically not what you hear in general chemistry since everything is an aqueous solution. Practically speaking, in the lab you will be using real glassware made of borosilicate glass, and instead of Bunsen burners you will be using heating plates. Because when everything's an aqueous solution, you can get away with using plastic glassware, but once you get into organic chemistry, everything's going to react with each other. The Lewis base is also called a nucleophile, meaning something that loves nuclei, aka protons, aka positive charge. On the other hand, electrophile means something that loves electrons, aka negative charge. Now in general chemistry, you would have been like, okay, HCl is an acid and NaOH is a base, but in organic chemistry, it actually depends on what all is being mixed. In general chemistry, the words acid and base kind of imply equal power between the two. And mathematically speaking, you could totally support that claim. But when operating under the Lewis definition of acids and bases, aka nucleophiles and electrophiles, the base is the main driver, so you will hear the word nucleophile far more often. The main reason being that the nucleophile has electrons to use and thus drives the reactivity. Sure, the word electrophile sounds equal, but what that really means is that you're missing electron density, and you are far more unstable without electrons than you are with it. So in organic chemistry, you have to look at the two molecules that you're reacting together and determine which one is the nucleophile. And the verbiage that we use is that the nucleophile attacks the electrophile. So what is electron rich attacks what is electron poor. Now in my class, we received a pKa chart that showed us all of the different molecular structures and their corresponding pKa's. Because depending on what you're reacting together, one reaction's nucleophile might be another reaction's electrophile. So we needed the pKa's to show us what would be stronger and what would be the nucleophile in that scenario. The answers in organic chemistry going forward are less like yes and no and more like yes, but in this situation, no, but in that other situation. If you like this content, please be sure to share it with a student who definitely needs it this year. And I will see you in my next video. Bye guys!